Hello, this is Peter Bartholomew here. What I'd like to do today is run through some of the changes that have appeared within Excel over the past couple of years. In September 2018 at Microsoft Ignite conference held in Florida, Joe McDade introduced the long-awaited dynamic array functionality that had just been made available on the Insiders channel. The new functionality has the potential to create seismic change in all areas of spreadsheet modeling. But for a number of reasons, that change may actually be slow in coming. The main unknown is whether the user can adjust their development practices. Not many developers actually work with array formulas to any great extent, which is curious when you consider the fact that at its core, every single calculation Excel performs is an array calculation. There is no such thing as a scalar variable in Excel, only 2D arrays. The example that I'll use for demonstration purposes is drawn from accountancy and financial modeling. That despite the fact that it's far from my area of expertise. What I want to cover is the use of defined names, which is something that I've employed from well before the era of dynamic arrays. I want to have a look at dynamic array formulas, what they do, how they work, and then to finish up with the let function, which is a new function on the Insiders channel that hopefully will be appearing in mainstream 365 sort of over the next year. So if we return to the example, looking at capital expenditure and depreciation, and I've chosen to assume that each item of expenditure is subject to linear depreciation in the following years. And of course there may be expenditure in sequential or various years along the timeline. So we're on the spreadsheet now, and let's build a solution. The first thing I need is a period counter, the timeline, and that is achieved with a newish dynamic array formula, which is sequence. And you start with a number of rows, which is 1, columns, which is model periods, and that gives me my timeline. Just to see that it's behaving itself, 10 grows back to 8 again. Put a couple of initial capex items, that's 900s and 1500s, say. And the depreciation takes place over 3 years, so that'll be a 300, 300, 300 and a 500, 500, 500. The spread is a third each year, so that is sequence 1, 3. I want it to start at 1, but I don't want it to increments, so increment step 0, and that should give me a row of 1s, divide by the period, should give me a row of 1/3, just there on cue. So let's again see that's working. Let's do a 5-year depreciation instead, so that looks okay. The next calculation that I want is to show the depreciation figures stepped back in time. So something that will be useful is yet another index array to show me which depreciation year I'm considering. What happens here is that I want to pick up the capex. So let's have a look at what capex is. So I now want to offset these values. So that will involve index and the period, but minus 1. But I only want that if the period is greater than naught. If greater than what? Greater than 1. Period. So I've moved that successfully to the right. Now I just need the next row to move 2 to the right, the next one 3 to the right. So to do that, instead of offsetting 1, I will pick up the depreciation year and pick it up on the inequality as well. And that gives me my depreciation array of where things are coming off. The actual depreciation would involve a further multiplication by the transpose of the spread so those are the actual amounts that are coming off each year. What I want to do now is sum the columns. Very easy from the viewpoint of single cell relative referencing, but surprisingly difficult using the dynamic arrays. There is no sum columns function. So what I'll do instead is use matrix multiplication. I'll also use the let function to introduce that and just use this as scratch space. So deviating for a moment and introducing the mmult function, matrix multiplication. What that does is that it takes a row and multiplies cell by cell into a column. And with these, once it's done this pairwise multiplication, it then sums and gives you a total. If you'd transposed this as I did before, then you could see that it's the same thing as a sum product. But the advantage of doing it this way is that mmult will multiply the row into every column and produce an array of results. So it's an awkward function, but it's much more powerful. Returning to the spreadsheets now, putting that into action, that we have an mmult formula which involves the spread and the array and gives the correct results. Something else I'd like to show before we move on is the use of the let function. The let function will allow you to replace helper ranges by further lines within the formula. So to do that, equals let, and I will eventually call that depreciation. So a name and a formula, extract, and Alt Enter again, depreciation, and the output, which could be another formula, but says. So what I want to do now is to define the depreciation array here, and while I'm about it, also the depreciation year. And having calculated these things, I better actually use them correctly. Copy that name and overwrite the spilt range with the new name. Overwrite the spilt range with the new name. And that is no longer a spilt range, it's actually this name here. Let's have a quick check to make sure that I've got a good copy of the depreciation array. That is correct. So now going back into the formula, I will put it back to show the depreciation. This formula no longer depends on these rows. They could just go and everything is perfectly happy. Something else that's awkward with dynamic arrays is accumulations, so I'll just show how that can be done. One way of doing it is to use some ifs. Let's start off with capex and the periods up to and including the sequence of periods. So that looks okay. Do the same thing for the depreciation. So replacing capex by depreciation. And now to get the assets, that it's cumulative expenditure minus cumulative depreciation, and that's the chart with the assets, expenditure items and depreciation. Hope that's been informative. Thank you for your attention. Until next time.